Hey everybody, in this video we are looking at chapter 1 of Algebra 2, which is Equations and Inequalities, section 6, which is titled, I just want to say the right title, Other Types of Equations and Applications. And we're looking at exercise number 39, which is a word problem dealing with the structure of a distance equals rate times time, but it's dealing with two different um, things working towards a singular distance or a singular amount of accomplishment. So let's look at this example. It's on top of the screen and it reads, pollution in a river. Two chemical plants are polluting a river. If plant A produces a predetermined maximum amount of pollutant twice as fast as plant B, and together they produce the maximum pollutant over 26 hours, how long will it take plant B alone? Now, some of you might be like, I just made up an amount of pollutant and I did it from there and I figured it out how long it would take, yada, yada. But the problem is in the future, you're going to have these word problems where you're dealing with finding the derivative of this thing in calculus, and you're going to need an equation, and you need to leave the distance or the amount of pollutant as an unknown, and you can't just guess and check. So yes, some of you can get the right answer by like plugging in and just carrying on and doing what you want with that, but you need to know the technique, and that's more important. So let's buckle up. Okay, plant A produces the predetermined maximum amount of pollutant twice as fast as plant B, tells me the rate of plant A is 2 times the rate of plant B. When working together, that means I'm going to deal with rate plus rate. They produce a maximum pollutant, they max out, it takes them 26 hours, that's their time. And then they want to know how long it would take plant B to do it by itself. You could kind of figure this one out, if I'm going to be honest, with a little bit of common sense. However, not everything is what we call a direct variation. Um, when things are not direct variations, you can't really use common sense. So again, I can't stress this enough. Even if you get the right answer doing it your way, I'm proud of you. That's great. But I need you to know the technique and the strategy. That's what's important. So let's look at this, okay? So I'm using as my like foundation for this. That's a little bit too high on the screen, isn't it? I'm using distance equals rate times time, okay? The distance is the max amount of pollutant, all right? So that right there is max pollutant, A-N-T, I believe. All right. So that right there is the distance. Rate is the speed, time is the hours, but distance is just not miles or anything like that this time. So we have what is it, chemical plant. So there's plant A and there's plant B, right? Two plants working. If they work by themselves, could we fill in and carry on with each of them individually? Sure. However, let's let the rate equal R equal B for plant B. That means the rate of plant A is 2B. Okay. Now, when I'm doing this combined, that means that the D, max pollutant, or you could call it M, you could call it whatever you want to call it, okay, equals rate. I have two rates working together. I have B plus 2B, or B, 2B plus B, whatever, times time. And then the time was 26 hours, right? So that's going to go right there. Now, based on this, I don't have enough information to get what that max amount of pollutant is, but that's okay. I don't even need to know what it is, right? That means D equals 3B times 26, or D equals 78B. That's perfectly fine, okay? D equals 78B. Now we want to know, how long will it take? How long will it take? So that means now part two. Part two, we're going to solve for time when plant B is working alone. How long will it take? So we will have D equals rate times time again. Now the distance is what? It's 78b. We just figured it out. 78b equals rate. What's the rate of that plant? It's just b. We named it in the beginning times time. Now, this is also one of the ones where a problem where people might not see how to finish it, but you got to trust the process. See it through to the end. How do I solve for t? How do I get t alone? Well, I'm going to divide both sides by b. So t equals, so that's gone. T equals 78. Guess what that means? It will take plant B 78 hours by itself. There you go. That's your answer. It will take 78 hours for plant B to reach the maximum level of pollutant when it's working by itself. Okay, so go through that again. Think about it again if you need to, but that's all there is to it. That way it works perfectly fine. So I hope you liked it. The professor on the screen right now, this is my dog. This is Dallas with glasses on. I hope you enjoyed, and I will be making more videos assortment from sections 1 through 6 as per your request. All right, that's it for now. Adios.